All right, here we are at Plan B techniques. Remember, Plan A is always use U substitution. So now we see what we have to do if we can't use U substitution right away. So what we're going to do is go through and talk about each technique, but I'm not going to solve them. I suggest you solve and then check your answers on this final document, because I will put the answers on the next page. So the first technique will be separating the numerator. So that means the denominator stays, the numerator gets split into 2. So we then have 1 over x squared plus 1 dx plus x over x squared plus 1 dx. Now if you look at the first one, that matches a pattern of the new formulas we just talked about, arc or inverse tangent. The second one, we are back to Plan A and U substitution, where U would be the denominator, and then the numerator would get taken care of, and we end up with a natural log, which we all love. Now, sometimes we have to expand the numerator first and then separate it. So just as a little algebra flashback, if we think of a plus b quantity squared, that's a squared plus 2ab plus b squared. So what we need to do is square out or multiply out the numerator first, and then we can split and go back to the first technique. So we have, when we multiply that out, is 1 plus 2e to the x plus e to the 2x all over 4 dx. And now we can split up the numerator like we did in that first technique. So we end up with 1 over 4 plus e to the x over 2 plus e to the 2x over 4 dx, and of course we can integrate each of these separately. Remember, integrating e to the x is e to the x, e for easy. Now, caution, so we'll put this one in red, we cannot separate the denominator. So we cannot change this integral into 1 over x squared plus 1 over 4. No. Angry face. Okay. So make sure, avoid that mistake. Alright, now we really have to go back to algebra and think about completing the square. So if you think back in algebra days, maybe you had a problem like x squared plus 6x plus something, and we wanted to change it to be x plus 3 quantity squared, and we called that completing the square. So maybe you remembered it as half of b squared is what goes in there for c. So in this case it would be 9. But you have to be careful because we've now changed the problem, so it's like if you add 9 you then have to subtract 9. So how does this apply to integration? So if we look at our denominator here, I'm going to take it out. I'm going to factor out the negative just because it's easier to have x squareds that are not negative, and leave spaces. The same number goes in each of these blanks. So what number do I need to complete the square? Well, half of negative 2 is negative 1, square it 1. But if I add 1, I subtract 1. So now I have negative of x squared minus 1 quantity squared, and that matches with this. And then I have minus 1, so that gives me a plus 1. So this is what now will go inside the square root here. So I rewrite my integral 1 over the square root of 1 minus the quantity x squared minus 1. Oops, x minus 1, not x squared. And it appears we have the arc sine pattern. So u, in this case, would be x minus 1. Now we think, okay, if we're back in algebra, let's just go back and more in algebra. Long division. So that's numerator divided by the denominator. And what's left over up here is what we're going to be integrating. So our long division, we have x squared plus no x's plus no constants divided by x squared plus no x's plus 1. X squared goes one time to make x squared, no x's, 1, subtract negative 1, so that's the remainder, so minus 1 over x squared plus 1. So here is now what we're going to integrate. So 1 minus 1 over x squared plus 1 dx. So the good news is, one's easy. In this one, oh, it's yet again another one of our patterns. This is arctangent. So now, flashback to pre-calc. Trig identities. Sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. And cotangent squared plus 1 equals cosecant squared. So what do we have cotangent squared? We want to replace cotangent squared using an identity, which will be cosecant squared x minus 1. So now we have to remember, how do we integrate trig? Well, who was cosecant squared? That would be negative cotangent x. And the really bizarre one, multiplying by what I like to call a funny version of 1. So if you look at this, well, if we rewrote it, x to the negative 1 is 1 over x minus 2x dx. Well, nobody really wants double fractions or complex fractions, if that name rings a bell. So we want to get rid of it. Well, how do I get rid of it? Multiply by x over x, which is just 1. So it's multiplying by a funny version of 1. So if I multiply everybody, I end up with 4x over 1 minus 2x squared. And the good news about doing the funny version of 1, we now can use u substitution. So your homework on the other example sheet is to just identify what each problem needs in order to integrate it. You are not going to actually finish and solve them. I would suggest you finish the problems on this page, and I will have worked out solutions posted to the website.